In the last lecture, we talked about percent concentration. In this lecture, we're going to talk about another type of concentration called molarity. In the last lecture, remember we covered mass, volume, and mass-volume percent concentrations. This last concentration we're going to cover does not involve percents. So molarity, the abbreviation for molarity is capital M. The definition of molarity is moles of solute over liters of solution. Keep in mind that we do not multiply by 100. So do not multiply by 100 for molarity. So we haven't dealt with moles in a while. Units 3 and 4 we didn't really talk about moles. So just to refresh your memory, how do you convert grams to moles? Use molar mass. And where do you get the molar mass? You get that from the periodic table. So if you're given a certain quantity in grams, that's your starting quantity. To use the molar mass to convert from grams to moles, you're going to divide by the molar mass. So divide by molar mass. So sometimes when you're given a molarity problem, you'll be given a quantity in grams, and before you can calculate molarity, you have to convert the grams to moles. Also, you could be given a volume in milliliters, and you have to convert it to liters before you can use molarity. So remember, if you're given a number like 262 milliliters, to convert that to liters, you can divide by 1,000, or you can move the decimal place 3 to the left. So 0.262 liters. So definitely knowing how to convert grams to moles, and moles to grams for that matter, as well as milliliters to liters will be useful when dealing with molarity. Just like the other concentrations we saw, mass, volume, and volume, percent concentrations, molarity can be used as a conversion factor just like they were. So, here is a typical question that you will come across when dealing with molarity problems. How many moles of HCl are there in 32 milliliters of a 3 molar solution? So when you come across a problem like this, I strongly encourage you to cross out mole, the big M, and write moles over liters. That way you'll see how units can cancel. So this is your conversion factor, while this is your starting quantity. So I'm going to write out 32 milliliters of solution. Put that over 1. This conversion factor, 3 molar, can be written 3 moles over 1 liter, or 1 liter over 3 moles. Notice that my denominator or numerator in either case deals with liters, not milliliters. So before I can even use my conversion factor, I have to convert the milliliters to liters. So liters, milliliters, 1 liter has 1,000 milliliters. So cross out milliliters, now I'm in liters. Now I can use this conversion factor. 3 moles over 1 liter. Liters cancel out and I'm in moles. So for sig fig, I can only have 2 sig figs because both of these numbers have 2 sig figs. I end up with 0.096 moles of HCl. Okay, so that's one way you can see molarity used as a conversion factor. Another way is this type of question: how many liters of solution are in 10.2 molar HCl solution with 21 grams of HCl? Again, whenever you see the capital M, cross it out and write moles over liters. This is our conversion factor. This is our starting quantity. So I'm going to write 21 grams of HCl over 1. In order to use molarity, I need to have units of moles or liters, and grams is neither of those. So I need to convert my grams to moles. So if you look up the molar mass for HCl, it's 36.46 grams, 1 mole. So this is HCl molar mass. Grams cancels out. Now we're in moles. So you can use molarity. So 10.2 in moles will always stay together. So I need to use molarity like this. So the 10.2 stays with moles. 1 goes with the liters. So the question asks for how many liters. So 21 divided by 36.46 divided by 10.2 gives you 0.056 liters of solution. So this is how molarity can be used as a conversion factor. Keep in mind that it's not a percent concentration, so you don't need to take it out of 100 like we did with the previous lecture. So bear that in mind. Let's go on to the next page. And question 1, I want you to read this question. What is the molarity of a solution that contains 50 grams of vitamin B1 hydrochloride in 160 milliliters of solution? I just went over how to use molarity as a conversion factor. And in this question, there is no conversion factor. So you might be thinking, oh my gosh, I'm so confused. I don't know what she's talking about. Be careful with this one. Read the problem very carefully. I am looking for molarity. You know what the definition of molarity is, right? Molarity, it's abbreviated with the capital M. So molarity is moles over liters. What I need to do with this problem is plug in the number of moles, plug in the number of liters, calculate the molarity. Am I given enough information to calculate the molarity in this problem? Yes, I have grams, given the molar mass. I'm also given milliliters, which I can convert to liters. So let's do those conversions separately. So we need to convert grams to moles. So I'm going to take 50 grams over 1, convert that to moles. I gave you the molar mass, so I just need to divide by that. 337 grams, 1 mole. So when you divide that out, 50 divided by 337, you end up with 0.148 moles. You're going to take that number and plug it in right here. So 0.148. Now I need to figure out what the number of liters are. So I have 160 milliliters. I need to convert that to liters. Move the decimal place 1, 2, 3. So my answer is 0.16. Be careful on this. A lot of students will say, put a 0 right here. But 160, look at that number very carefully. That only has 2 sig figs. So do not put a 0 there, because that would make it have 3 sig figs. So I'm going to carry this number over here. I get 0.16 liters. Now, am I done yet? Have I calculated the molarity? No, I still have to divide 0.148 by 0.16. So I end up with 0.925 m, 2 sig figs, 0.93 molar. So there's your answer. Okay. So, just like with all the other problems, all the percent concentration problems, you can be asked a problem 3 ways. You can be asked to calculate the concentration. We just calculated the molarity. Then you can be asked for the amount of solute given using a concentration and molarity, or you can be asked for the solution using a concentration and molarity. So just be on your toes. Read the questions carefully. Try to identify starting quantities. Try to identify if you're being asked to solve for a concentration. I want you to hit pause and work through problems 2 through 5. Okay, so on number 2, you were again asked to calculate the molarity, just like in number 1. The only thing you really had to convert was 200 milliliters to liters. So you convert 200 milliliters to liters, divide through to find the molarity. And you have 3 sig figs, so it's 0.500 molar. Number 3, again you were asked to calculate the molarity, but you had a little bit more work to do than in number 2. So you have to convert grams to moles and then plug that in here. I didn't mean to use a highlighter, but I did. And then you also have to convert liters, milliliters to liters, and plug that in here. So you can have 4 sig figs, so your answer comes out to be 1.507 molar. Number 4, you're using molarity as a concentration, but I didn't give you the formula of calcium nitrate. So I made it tricky for you. I'm trying to get you guys to review for the final, so hopefully you were able to come up with a formula of calcium nitrate. The formula, by the way, is CaNO3 2. So when you calculate the molar mass, you have 1 calcium atom, 2 nitrogen atoms, and 6 oxygen atoms. For a quiz or exam in Unit 5, I will give you the molar masses. You won't have to take the additional time to calculate those, but you will definitely need to know how to do this on the final, so you're getting practice now. So the molar mass you end up with for calcium nitrate is 164.1 grams, and then you convert, so you've got those to cancel, then you use the molarity, get those to cancel out, so you're in liters, and then convert liters to milliliters, because I asked for milliliters of solution. So make sure you read the question. What units do I want it in? So the answer, 3 sig figs, 331 milliliters. And then the last problem, what is the molarity of a solution made by dissolving 2.355 grams of sulfuric acid in water and diluting it to a final volume of 50? So I'm asking for a molarity again. So that means that you have to find the number of moles, plug it in here, convert milliliters to liters, plug it in here, and then adjust everything to the correct number of sig figs. So you end up with 0.480 molar sulfuric acid solution. And again, I made you look up the molar mass for sulfuric acid, so I was making you work for it. But that's molarity. we have learned 4 concentrations. We learned mass percent, mass volume percent, volume percent, and molarity. So keep in mind that molarity is the only one that's not a percent. So 4 concentrations. We have mass percent, volume percent, mass volume percent, and then we have molarity. These all involve multiplying your solute over solution times 100. Molarity does not. Molarity is just moles of solute over liters of solution. So you don't multiply molarity times 100. So we've seen how we can use these concentrations. We can use them as conversion factors. We can also be asked to find the concentration. So be prepared for seeing it every possible way. And remember to pay close attention to your units and sig figs. So if we go back to the notes, I'm going to stop here for this lecture, and we'll talk about dilution in the next lecture. So continue working on your concentration lab, work on your pink book problems, also work on your homework problems. Until next time.